full architectures to solve many complex natural language processing problems. Basically, there are two ways to implement the algorithms when working with the subject: the basic techniques of natural language processing, NLP, and more advanced techniques using deep learning, which are artificial neural networks. All the algorithms that we are going to implement are based on these most basic techniques, and these two libraries, PySummarization and BERT, are based on deep learning. It is important to emphasize that the focus of this course is on NLP techniques, and we are not going to implement neural networks. And there are two ways to generate the summaries: abstractive and extractive. The algorithms that we will use in this course are based on the extractive technique. Mathematical calculations are made in order to indicate which are the most important sentences. No changes are made to the original text. As you can see here, we have the full text, and the sentences highlighted are considered the most important according to the algorithm. In other words, each sentence will have a score, and the sentences with the highest score will be selected. On the other hand, abstractive techniques will not select the most important sentences, but will create new texts based on existing texts. It is as if you were a person who reads the text and creates your own summary. However, it is also important to emphasize that in this course, we will only work with extractive techniques. If you have never heard about text summarization, at the end of the course, you will have the theoretical and mainly the practical background to develop your own projects. Here you can see a Google Colab file, so it means that all cores will be implemented step by step using Google Colab. So it won't be necessary to install libraries in your machine. So it will be easier to follow the course. And here you can see some of the code. This is the frequency-based algorithm. As you can see here, all lines will be implemented step by step. And here in this part, we have the generation of the summary. You will also learn how to extract text from the internet. For example, we can specify a link. And here at the end, we can see the results. Now let's quickly talk about prerequisites. You need to know about programming logic and also some basic Python programming. The level of the course is beginners, so this course is suitable for who are starting working with text summarization or natural language processing. And that's it for this lecture. In the next one, you will have some theoretical background about natural language processing, mainly some interesting applications, and right after, we will move on to the algorithms. I hope you have a great course and enjoy the content. See you next time! Hello and welcome to this lecture where you are going to learn a basic introduction to natural language processing. Mainly, we will see some interesting applications that can be developed. You can feel motivated to study this area if you know some of the applications. The first one is speech transcription. You speak and the corresponding text is generated, or you write and the algorithm reads the text for you. The area of natural language processing is related to both written and spoken language. The second application is neural machine translation, which is translation between languages. For example, English text can be translation is neural and natural language processing is related to both written and spoken language. The second application is neural machine translation, which is translation between languages. For example, English text can be translated into Portuguese, Chinese, Spanish, and many other languages. The next application is the chatbots that have been used on a large scale by companies to serve customers. Instead of talking to a human attendant, customers can solve some problems by talking to machines. The interesting point is that currently chatbots can interact both by spoken and written language. The next application is Q&A systems that are very useful in question and answer forums, as the name suggests here. This type of application is useful for searching similar answers, so there is no need for a person to answer frequently asked questions. The next application is text summarization, as you can see in this image here. We have the full text on the left side, then we apply some specific algorithms, and on the right side we have the summary. So the summary contains only the main part of the text. This type of algorithm is very useful for those who are in the academic field, for example, studying in a master or PhD course. In this scenario, students need to read a lot of papers a day, and he or she does not have enough time to read all of them. So, a summarization algorithm can be applied, and the student will need to read only the summaries that contains what is most important in the texts. For example, instead of reading 10 pages, the student can read only 5 or 4 pages. This other image here shows image captioning, which is the generation of descriptions for images. For example, if there is an image of a black dog jumping over a fence, the algorithm will interpret the image and add that description. This type of application is very useful to help people who have some difficulty seeing. We can see this other application, which is video captioning, which aims to generate captions for videos. For example, while I'm talking now, some automatic captions are being generated according to the words I'm speaking. The last application is sentiment analysis, which aims to find out if a text is positive or negative. It is very useful for companies to analyze what their customers have been saying about products and services. For example, the company can post something on a social network and check the feelings that this post is generating. The focus of this course is only on text summarization here, so you will learn some algorithms in order to generate the summaries. And
So we've seen how to do speech-to-speech translation. This is speech-to-text. Now we've seen speech-to-text when it comes to transcription prior to this in this course. So we're going to be very similar, except this is going to change the language along the way. We're using the SDK Cognitive Services Speech API. All the same setup. We're basically setting up the translation configuration. We're setting up the from language being English and the to language being German. And so by setting up this translation configuration, now we're basically telling it this is what we want to use. We want to use
In this video, you will learn how to extract text from an audio. So from audio format to text format. The audio file that we'll be using for this example is this one in here.
September 11th, 1973, a military coup overthrows the government in Chile, ending the longest
etc. So what we're doing is basically speech recognition. And for this, we will be using the speech recognition library. It's a third-party Python library. And the central object of speech recognition is the recognizer. So recognizer is a class that allows us to create a recognizer instance. Once we have a recognizer object instance, we need to use a with context manager for this. And we need to create an audio file using the audio file class. So audio file is something that we need to import from speech recognition. So together with recognizer, we have audio file. The audio file gets as inputs, guess what? The actual audio file on disk, so the file path of that. With audio file as audio file, this is just a variable, and then we use that variable further here, but first we create another variable, which is this audio, and in this variable, so we need to grab that audio from the audio file. This is the actual audio file, this will be the audio. So to fetch the audio, we need to use the recognizer and the record method of a recognizer object type. The record method now gets that audio file as input. So we record the audio of that audio file. That's the idea here. And then you exit that with block and you create another variable. So let's say text that is equal to recognizer.recognize Google. So there are various methods that a recognizer object instance has. And the one we're using is recognize Google, which is tied to the Google speech recognition API. Other methods use other APIs. Some of them need you to create an account and have an API key, but Google does not. So this is the easiest one to use. Recognize Google, and guess what we need to input here? So we need to recognize from audio, that one. And lastly, all we'll have to do is print out the text. So text will be a string data type. So run. Make sure speech recognition is installed. Yeah, that's the case in my REPL, and run. And that's the output. So September 11th, 1973, military coup. Let's compare it. I don't expect that to be 100% accurate, though.
September 11th, 1973, a military coup overthrows the government in Chile,
Quite good,
ending the longest
actually.
democratic
Well,
tradition in Latin America.
some
It
errors.
was a bloody coup.
Chileans who lived through the coup and years of repression reflect on its meaning for us today. Isabel
So
Allende
this is a
and
bit
others.
challenging for the algorithm because it does have some music and some other sounds on the background, but still I think it's doing a good job. And that is how you do speech recognition in Python. That's the basics, but we will have some interesting apps using speech recognition later on. So stay
Do
tuned.
you
and
have
I'll
a
see you
lot
in the
of
next videos.
videos lying around, perhaps from YouTube? It will essentially read in the file.
Hello and welcome to the first section of the course on text summarization in Python. In this lecture, I'm going to show you the plan of attack. As you can read right here, the goal of this section is to present you the simplest algorithm in order to work with text summarization, which is the frequency-based algorithm. Now let's see the main topics that will be covered in this section. In the first topic, you are going to learn the mathematical calculations, and right after, in topic number 2, we will implement it together in Python. We will also compare the theoretical results with the practical results. At the end, you will be able to compare the original text and the summary and check if in fact the algorithm is returning good results. In topic number 3, you are going to learn how to generate summaries using articles extracted from the internet. You are going to learn how to extract some texts from Wikipedia pages, and then we will apply our algorithm. This image shows the final result that we will implement, the full text, and in yellow, the summary with the selection of the most important sentences. In the next lecture, you will understand the intuition, and right after, we will move on to the implementation. See you there! Hello and welcome to this lecture, where you are going to learn the intuition about one of the most basic algorithms for text summarization, which is based on the frequency of words. Let's consider this initial text that has several sentences about artificial intelligence. For example, artificial intelligence is human-like intelligence. It is the study of intelligent artificial agents, science and engineering to produce intelligent machines. Solve problems and have intelligence related to intelligent behavior, developing of reasoning machines, learn from mistakes and successes, and finally, artificial intelligence is related to reasoning in everyday situations. This will be the text that we will use as a case study in order to understand the mathematical calculations. Just a reminder that the goal is to select the most relevant sentences of this text here. To reach this goal, we need to follow a sequence of 7 steps, as you can see here: the preprocessing of the texts, the calculation of the frequency of the words, and also the definition of the weights or the importance of each one of the words. Then we move on to the next step, which is the tokenization of the sentences. After that, the assignment of a score for each sentence, the ordering of the best sentences, and finally, the generation of the summary considering only the most important sentences. Now you are going to learn step by step each one of these steps here. Let's start by understanding step number 1, and here you can see the original text and just below the preprocessed text. We have the application of 3 types of processing. The first one is the change to only lowercase letters. Above, we have uppercase and lowercase letters, and here we have only lowercase letters. It is important to change the text because if we have this word here, intelligence, with lowercase letters, and again the word intelligence with capital letters, the algorithm will consider both as different words, so we need to keep them all in the same pattern. The second preprocessing was the removal of some stop words. For example, this word is not being used here. It is the, it's not being used in the preprocessed tests. The word of is not being used here. Also, the word and, have, to again, of, from, and, is, to, and finally the word in. The words that were removed are called stop words, and they are removed because they are not so important for understanding the meaning of the sentence. Finally, the punctuation has also been removed from the texts, as you can see here, here, and here at the end of each one of the sentences. And this is the first step of the algorithm. The second step is to select each one of the words that are in the preprocessed text and count how many times each one of them appears in the text. In the left column of this table here, we can see the words, and in the second column, we can see the frequency. For example, artificial equals 3. It means these words appears 3 times in the preprocessed text. We can take a look here, 1, 2, and finally 3 times. The word intelligence appears 4 times in the preprocessed text. We can take a look here, 1, 2, 3, and finally 4 in this part of the text. And a lot of words appear only 1 time. For example, human, like, study, and all those words here on the right part of the table. We can assume that the more a word appears, the more important it is. The frequency calculation is used in step number 3, which is the association of weights for each one of the words. We will use the word that appears more often in the text, which is intelligence, and it appears 4 times, according to this table here. You can see here another table like the one we have been discussing with the addition of a new column. The weights for the word artificial is 0.75, and to get this value, we simply divide the number of times the word appears by the highest value. Let's open the calculator in order to perform some tests. For example, artificial appears 3 times in the text. 3 divided by 4 equals 0.75. Let's consider this other word here, machines. It appears 2 times in the text. 2 divided by 4, the highest value, the result is 0.5. We can take a look at some other words. Human, it appears only 1 time in the text. 1 divided by 4, which is the highest value, the result is 0.25. And we can take a look, that's the weight for the word intelligence is 1, because we divide 4, the number of times this word appears in the text, by 4, which is the highest value. The result is 1. So it is considered the most important word. The purpose of this algorithm is to select sentences that contain words that appear more often. In short, sentences that contain the words intelligence, artificial, and also intelligent are more important than sentences that contain these other words here that appear less often in the text. The next step is sentence tokenization, and the goal is only to separate sentence by sentence. See here, we are using the original text without the application of the pre-processing step. In this example, we can consider the dots here as the sentence delimiter, and here is the result, sentence by sentence. This is a very easy step. Now that we have the sentences, we can move on to step number 5, which is the calculation of the score for each one of them. We use the values of the weights that were calculated before, and we simply add the values. For example, for the first sentence, the value is 3.25. We just add the weights. For example, 0.75 plus 1, the weight for the word intelligence, plus 0.25, the weight for the word human, plus 0.25, the weight for the word like, and finally, plus 1, the weight for the word intelligence. See here that the result is 3.25, and we perform exactly the same calculation for each one of the sentences. Please note that we do not consider stop words here. For example, the word is not considered. The words it is the are not considered for the calculations. In this part of the table here, you can see the sum and the scores for all other sentences. The higher the value, the more important the sentence is. On the other hand, the lower the value, the less important the sentence is. We can see that there is a tie between two sentences, the first and the last one. Both have the same score. And this one here, learn from mistakes and successes, has the value 0.75. So it is considered the worst sentence. After calculating the score, the next step is to order the sentences according to the score value, as shown in this table here. In order to create the summary, we need to define how many sentences we will select, and it depends on the size of the text. The larger the text, the more sentences must be selected. As there are only 8 sentences in this text, we can select the 3 most important ones. See here that we have 3.25, 3.25. Both sentences are considered the best one. In the third and fourth place, we have again a tie. The value is 2 for each one of the sentences. And again, the worst sentence is this one here with the lowest value. And this is the last step of the algorithm, in which we combined the main 3 sentences to generate the final summary, as you can see here. Above, we have the original text, and below, the summary. In the next lecture, we will start the practical implementation of this frequency-based algorithm. See you there! Hello and welcome to this lecture, where we are going to start the implementation of the frequency-based algorithm in order to summarize the texts. We already have this Google Colab file, and if you are new to Google Colab, you will have access to this file here, and in order to run or to make changes to this notebook, you must click on File, Save a Copy in Drive. When you click this link, a copy of this notebook will be made on your own Google Drive. So you must have a Google account and be connected to it. I will click this button here, Connect, in order to connect this file to the Google servers. And initially, we will use the same example as the theoretical lecture in order to compare the results of the slides. Right after, we will extract a text from the internet in order to apply our algorithm. The first step is the pre-processing. Let's open a new cell of codes and let's import some libraries. The first one, import. RE, it means regular expression. This is a Python library in order to find patterns in texts. Let's import. NLTH, it means Natural Language Toolkit. This is one of the most famous libraries to work with natural language processing in Python. And finally, let's import string in order to have access to some features that we are going to use later. Let's run this cell of code. No error was returned, so it means that all libraries were correctly imported. Let's create the original text, and I will just paste the code here. You can see that this is exactly the same text that we have been using in the theoretical lecture. See here that we have 3 quotation marks, and we use it in order to skip the line after each one of the sentences, so it is easier to read the text. If you don't use these quotation marks, you need to type the code like this, a sentence after another, so it will be difficult to read. For this reason, we are using these quotation marks. Let's create this variable. We can take a look at the content. Let's type original text, which means these spaces here after we skip the line. And we also have this symbol here, bar n, which means that we are skipping the lines. So we need to remove these characters in order to be easier to pre-process this text. Let's recreate this variable, original text equals RE, the import that we perform for regular expressions. Let's type R in order to define our expression. And to find the empty spaces, we can type this symbol here, bar and S. It means that this library will go through all this text and it will search for these empty spaces. When it finds the empty spaces, we will replace by only one empty space. And here we put again the original text. As we have more than one space, we can put this symbol here. It means that we may have one or more empty spaces. Let's run this code. It's missing the word sub here. Run again. Let's take a look at the original text and see here that we don't have this symbol, and also we don't have the empty space anymore. And in the next lecture, we are going to continue the implementation. See you there. Hello and welcome to this lecture, where we are going to continue the implementation of the pre-processing step. As we can see in this slide, we have the original text and we need to apply some pre-processing. For example, we are going to change the letters to only lowercase. Also, we are going to remove the stop words, and finally, we are going to remove the punctuation. In this lecture, we are going to implement all these three pre-processing steps. Let's create a new function, def preprocess, and it will receive as a parameter the text. Let's create another variable, formatted text equals text dot lower. This code here will change the text to lowercase. We can return the formatted text. Let's create this function and perform the first test. I will open a new cell of code. code. Let's create a new variable, formatted text equals, and let's call our new preprocess function, and I will send here our original text, which is this text here. Let's take a look at the variable, formatted text, run this cell. See here that all the words were changed to lowercase letters. This is the first step of the preprocessing, and in the next step, we're going to remove the stop words. In order to do that, let's create a variable called tokens in the format of a list. When we open and close brackets, it means that we are defining a list in Python. So we are going to go through each one of the words and store each one of them in this list here. Let's implement a for loop for token in NLP key, which is the natural language toolkit in order to work with natural language processing in Python. And there is a function called word tokenize, and we are going to send here the formatted text. So we are going through each one of these words, and we are going to check if each one of them is considered a stop word. But first, let's add to this list tokens.append token. Let's run this code and try to run this function again. An error was returned because we need to execute this code, nltk.download, and in order to use this word tokenize function, we need to download this package here. So I will create a new cell of code. Let's paste this code here, run again, see that the download is complete. If you see this message true, it means that's the download and the
This whole time I was muted. God damn it. I don't understand why my Streamlabs be like, it starts up with no goddamn, man, it's so annoying.
The installation was done successfully. Let's try to run this code again. Call the function. No error was returned. Now we can take a look at this list after the for loop. Let's print tokens, run.
Literally what I was about to do. Print tokens. Oh, it's commented out. App data. Roaming. NTLK data. NLTK. It's not here. It doesn't exist. What? I don't need to see all this shit. Yeah, and I don't need to download it every time. Artificial intelligence is like, it is the study of, yeah, sounds about right. Fuck. Okay, this is good. I don't need to download it every time. But stop words. good. We good.
Run again, call the function. See here that there is a list, and in each position of the list, there is a word, or in other words, there is a token. This function, word tokenize, will go through each one of the words and it will separate them. So now we can access each one of them and check if they are or they aren't stop words. And in order to do that, we need to download another package, nlp.download stop words. Let's run this code. If you see this message through here, it means that the download and the installation was done successfully. I will create another variable, stop words equals nlp dot corpus dot words, and here we can set the language that we are using. As we have an English text, we can type English here. If you are developing a text summarizer for other language, you just type the name of the language here. Let's print the stop words. An error was returned because it's missing after corpus stop words. Let's run again. See here that we have in the format of a list some words that we are going to remove. For example, I, me, my, myself, and so on. Let's check how many stop words we have in this list. Length stop words. The result is 179. So this is the total amount of words that we are going to remove from our text. And it is quite simple to do that. Tokens equals open and close brackets in order to define this variable in the format of a list. I will create a new variable called word, and let's implement a for loop for words in tokens. This for loop here is going through each one of the tokens. At the first time we execute this for loop, it will take the word artificial, in the second time the word intelligence, in the third time the word is, and so on. And we are copying each one of these tokens to this variable here. So now we need to verify if this word here is in this list here, in the stop word list. So we can implement an if statement. If word not in stop words. So we are going to select the words which are not inside this list here. Instead of returning the formatted text, let's return the tokens. Run again. There is a typo here. It's missing in for words in tokens. Let's create the function again and let's test. See here now that we have each one of the tokens and we don't have stop words anymore. For example, the word is was not returned. It is were not returned by the function because actually they are considered stop words. And the last step, we need to remove the punctuation, and in order to do that, we can type string.punctuation. In this list here, there are a lot of kinds of punctuations that we may remove from the texts. For example, exclamation mark, open and close brackets, open and close braces, and so on. See that the dot is here. Now we are going to add a new code here, and word not in string dot punctuation. So we are selecting the words that are not in the stop word list and also are not in the punctuation list. Let's run the function again. Run this code here. See that now we don't have stop words and punctuations anymore. And the last step, in order to finish the implementation of this function, is to transform this list here in the format of a string, because we need the same format we have here. In order to do that, we are going to use a code to concatenate all these strings here. I will create a new variable, format text equals, and let's join all these tokens with an empty space. And let's implement a for elements in tokens. This for here is exactly the same we implemented here in order to go through each one of the tokens, and we are joining with an empty space. Let's return the formatted text, create the function again, let's perform the test, and now we can see the final result. Just a reminder that we changed the letters to lowercase. After that, we removed the stop words, and finally, we removed the punctuation. And in the next lecture, we are going to start the second step of the algorithm, which is the word frequency. See you there! Hello and welcome to this lecture, where we are going to implement step 2 of the algorithm, which is the word frequency. Last class, we implemented the preprocess function, and now we have the preprocess text. And the result is the pre-processed text, as you can see here, and the goal now is to find the unique words in this text and count how many times each one of them appears on the text. Let's open a new cell of code. I will create a new variable called word frequency equals NLTK, and there is a function called frac_gist, which means the frequency distribution of the words. And now let's send here the formatted text, the text that was preprocessed in last lecture. Let's take a look at this variable, word frequency, and see that it is counting the characters and not the words. For example, letter A appears 19 times, letter B
I need my lugs. I need my lugs.
E 2 times, letter C 14 times, and so on. And in our
I'll continue this shit tomorrow.